Late in 2025, something began unfolding in the skies that left even seasoned astronomers speechless. Not one, not two, but 7 massive comets were spotted racing inward toward the heart of the solar system, all within a compressed 6-month window. For centuries, comet appearances have been scattered and irregular. Some years pass without a single one bright enough to see with the naked eye. But now, the heavens were suddenly crowded, as if the night sky itself had decided to stage an unrepeatable performance. The records were clear. In modern astronomical history, nothing like this had ever been documented. Normally, the world might get one bright comet every year or two, maybe 3 if luck was on humanity's side. But 7, and not spread out over decades but arriving almost back to back, their tails cutting across the same sky? It was beyond improbable. Astronomers didn't describe it as coincidence. They gave it another name. A swarm event. Something so statistically rare, so tightly compressed, that it demanded to be studied as a single phenomenon. The question hanging in the air was simple, yet unnerving. Why now? Why this year? And why so many? When the orbital data came in, the pattern looked less like random chance and more like choreography. This wasn't a slow drizzle of icy wanderers slipping in unnoticed. This was a concentrated rush. One comet after another threading through the inner solar system in rapid succession. Some were long-period travelers arriving from the frozen edge after eons in the dark. Others were familiar returners, circling back after centuries away. And then, like a cosmic wildcard, came 3 I/ATLAS, not even native to this system, an interstellar visitor from another star. Statisticians dug through the old logs. Even in the richest decades, no more than 4 comets had ever reached perihelion this close together. 4 was extraordinary, 7 was unheard of. And then came the detail that raised the stakes even further. Their orbits weren't scattered randomly. Instead, they clustered near the ecliptic plane, the same narrow path followed by Earth, Mars, Venus, and the rest of the inner planets. A crowded highway of worlds, and now, suddenly, a crowded highway of comets. That alignment alone was enough to send shivers down the backs of researchers. It meant that solar interactions were not just possible, but likely. Tail severings, plasma storms, magnetic reconnection events, all of them more probable when this many icy bodies swept so close to the Sun at once. Each comet carried its own story, its own place in the lineup. The first to mark the boundary was C/2022 Pan-STARRS. Quiet, distant, faint. Its perihelion placed it far beyond Mars, its glow too dim for casual stargazers, but its timing significant. It was the opening marker, the boundary stone that told astronomers the swarm has begun. Then came the true spectacle, C/2025 R2 Swan. Its orbit brought it terrifyingly close to Earth, just 37 million kilometers away. In astronomical terms, practically a near miss. For northern skywatchers willing to wake before dawn, Swan promised a display not seen in decades. A glowing head, a long, sweeping tail perhaps stretching 5 times the width of the full moon. It was the kind of comet that didn't need a telescope, didn't need a camera. You would simply look up, and there it would be. A cosmic intruder, visible to anyone with eyes. But Swan wasn't the only show. Racing inward just behind it came C/2025 CometATLAS. Its path would carry it closer to the Sun than even Mercury ever dares. That proximity meant instability. As its icy surface boiled, astronomers braced for violent outbursts, jets of gas, and possibly a spectacular tail disconnection as it crossed the volatile boundaries of the Sun's magnetic field. Atlas was the unpredictable one, volatile, dangerous, and capable of flaring without warning. And then there was C/2025 A6 Lemon, the comet forecasted to become the season's crown jewel. Predictions suggested it could blaze as bright as magnitude 3.5, visible to the naked eye in the cool November evenings. For millions of people across the Northern Hemisphere, Lemon would not be an academic curiosity. It would be the comet of a lifetime, a glowing reminder of how little control humanity has over the cosmic stage. Others added to the crowded roster, 414p/stereo, with its orbit dipping beneath the plane of planets, and 240p/neat, a fainter periodic returner. Together they filled the sky, each carving its own trail, each threading its path across the solar wind, each joining the rarest traffic jam in astronomical memory. Individually, these comets would have been remarkable. Together they formed a pattern so unusual that many couldn't shake the sense it was deliberate. Was this cosmic timing pure chance? Or was there something else at play? The interstellar arrival of three I/ATLAS only deepened the unease. To have a foreign body from another star slip in at the very same time as 6 local giants, the odds were so small that some began whispering that coincidence was no longer a sufficient explanation. For centuries, comets have been called harbingers, their sudden appearances linked with upheaval, war, or transformation. In 2025, as 7 of them streak inward, almost hand in hand, the world is left staring at the heavens and wondering, are these just icy relics, reminders of a chaotic solar system? Or are they messengers, aligned in time for reasons humanity does not yet understand? When comets dive toward the sun, they put on a show that no planet, no moon, no asteroid can ever replicate. Their frozen cores, buried under layers of ancient ice and dust, awaken as the heat of the sun floods across them. Suddenly, what was once an inert rock in deep space transforms into a living spectacle, sprouting tails that stretch across millions of kilometers. But what most people don't realize is that a comet doesn't just grow one tail, it grows 2. The first is the dust tail, pale, broad, pushed outward by sunlight itself and sculpted by gravity. This is the familiar streamer that arcs across the sky, a painter's brushstroke written in starlight. The second is stranger. It is the ion tail, electric blue in color, forged from charged particles ripped from the comet's surface and carried away by the solar wind. If the dust tail is passive, drifting with light, the ion tail is alive, a direct tether to the sun's invisible magnetic field. And unlike the dust plume, this electric tail is fragile. It can be severed in an instant. Scientists call it a tail disconnection event, and it happens when a comet collides with abrupt changes in the interplanetary magnetic field. A coronal mass ejection, a ripple in the solar wind, even a sudden crossing of the heliospheric current sheet, these invisible structures slice through the comet's plasma environment, snapping the ion tail like a whip. In minutes, the old tail floats away, drifting into deep space, while a new one grows in perfect alignment with the altered solar wind. The first time humanity saw this happen in real time was in 2007, when NASA's Stereo spacecraft recorded a CME slamming into Comet Encke. The video showed the tail ripping cleanly away, the gap forming near the nucleus, and the luminous streamer floating off into darkness. For the first time, magnetic reconnection, a theory often trapped in equations and models, was painted across the heavens for all to see. It was proof that comets weren't just icy relics. They were instruments, natural sensors that revealed the sun's hidden moods. Now, with 7 comets converging in the same season, aligned near the ecliptic during the peak of solar maximum, the odds of witnessing such events rise dramatically. The sun is already restless, hurling out 2 to 5 CMES each week. Every time one collides with a comet, the possibility of another tail disconnection looms. Except this time, it won't just be 1 or 2 comets under watch. It will be an entire swarm, giving scientists multiple chances to catch the spectacle in real time. And yet, not everyone agrees on what this means. Behind the scenes, a sharp scientific debate is raging. If you're fascinated by these revelations and want to keep uncovering the mysteries of our universe, make sure you hit that like button and subscribe. It really helps us bring you more stories the mainstream won't tell. NASA's CCMC modeling teams argue that this surge of cometary plasma and dust, especially from bodies traveling near the ecliptic, could do more than just trace the sun's activity. They could amplify it. Their simulations suggest that as a comet slices through a magnetic boundary, the geometry shifts. Energy builds. Sometimes the presence of that plasma reservoir may even trigger a CME, or accelerate an existing outburst. In this view, comets are not just passive observers. They are participants, tiny catalysts capable of nudging the sun into new states of instability. But rival groups see it differently. Teams working with the Parker Solar Probe and ESA's Solar Orbiter insist the models are overplaying the drama. To them, comets are not triggers, but tracers. The magnetic field lines drape around them, yes, but the sun's massive cycles are what truly drive the storms. Their instruments have cataloged countless cometary kinks and bends that never grew into full-tail disconnections, even during major solar events. They point to microscale turbulence, subtle reconnections, and background variability as the true culprits, dismissing the idea that these tiny icy wanderers could push a star into tantrums. The disagreement cuts to the core of space weather science. Can comets influence the sun, or are they just cosmic weather vanes pointing to changes already underway? With satellites, power grids, and astronauts at risk from CME activity, the stakes are more than academic. And yet, despite their differences, both camps agree on one thing. The 2025 swarm is a rare natural experiment, a once-in-a-generation chance to watch multiple comets dance across the sun's magnetic field at the height of solar activity. Every CME, every strange kink in a tail, every burst of light is now a clue in this standoff. But one comet in particular carries the mystery further than the rest. 3I/ATLAS. Unlike its companions, this visitor does not belong here. Its orbit is hyperbolic, its trajectory steep and final. It is not circling the sun in some long loop. It is passing through, never to return. Only two other objects, Oumuamua in 2017 and 2I/Borisov in 2019, have ever been confirmed as interstellar before it. And yet, here, in the same season as 6 other comets, Atlas has arrived. The odds defy belief. Early measurements from Hubble and the James Webb Space Telescope paint a picture that is as breathtaking as it is bizarre. The nucleus itself could be as small as 320 meters or as large as 5 kilometers. But the coma, the hazy halo of gas and dust it sheds as it heats up, has already swelled to 700,000 kilometers across. That's nearly the size of Jupiter, and it continues to grow week by week. Its chemistry is no less strange. Spectroscopy shows a dominance of carbon dioxide and exotic volatiles rarely seen in local comets. Water vapor is scarce, cyanide only faintly present. These are the fingerprints of a body forged in a different stellar nursery, carrying the secrets of alien chemistry into our skies. Its path confirms the origin. Skimming the ecliptic at only a 5-degree tilt, Atlas moves with a velocity that leaves no doubt it came from far beyond. But there is more. As it passes the sun, ATLAS leaves behind a trail of debris, and calculations suggest Earth may cross that stream in 2026. For planetary defense teams, this is no small detail. It means interstellar dust, particles older than humanity itself, could rain into our upper atmosphere, offering the first direct samples of material from another star system. To scientists, this is priceless. To others, it feels like a warning. Because Atlas is not just another comet. It is a messenger, a reminder that our solar system is not an isolated island but an open sea, crossed by travelers from distant shores. Some drift in quietly, others blaze through with drama. And in 2025, Atlas has arrived in the middle of a rare cometary storm, as if drawn here by design. 7 comets, 2 tails each, a restless sun on the verge of outbursts, a scientific community divided over whether these icy visitors are passive markers or active triggers. And at the center of it all, one interstellar giant with a Jupiter-sized halo, reminding us that the universe is stranger and far less predictable than we dare to imagine. For now, astronomers prepare. Instruments are trained, satellites poised, telescopes waiting for the first sign of a severed tail, a sudden flare, a stream of alien dust cutting into Earth's skies. The comets are coming, and with them, answers to questions that could reshape our understanding of both the sun and the stars beyond. But the deeper mystery lingers. Is this all coincidence, a statistical outlier written in the math of celestial mechanics? Or is the swarm itself a signal, a reminder that humanity's place in the cosmos is not as solitary as we once believed? One thing is certain. The season of comets is far from over, and the most important revelations may still be waiting, hidden in the glow of ATLAS's alien light.